In this video, we are going to prove that the root of 2 is irrational. To prove that the root of 2 is irrational, we will use proof by contradiction. Proof by contradiction. So how does this proof work? So proof by contradiction works in that we are going to make an assumption. Then we will write on that assumption to say that it is true. Then if we work out whatever we will work out and find that it is not true, meaning it contradicts, then it means that the first assumption that was made is false. Then the conclusion is that the opposite has to be true. Alright, so how are we going to do this? How are we going to do this? So we must first understand. So we are proving that the root of 2 is irrational. So we have rational and irrational numbers. So we are told to prove that this is irrational. So irrational. So to prove that this is irrational, using proof by contradiction, we must first suppose. So we say suppose root of 2 is rational. So we want to first suppose that it is what? Rational. It is not irrational. We suppose that it is rational instead. So if it's rational, then by definition, it means that it can be expressed in the form a over b, where b is not equal to 0. Where b is not equal to 0, and a and b have no common element. Have no common. Okay, it's supposed to be common, not come. Have no common factor. Have no common factor. Have no common factor. Alright, so this a and b must not have any common factor. So when we have 3 over 6, so 3 over 6, we can see that I have a common factor here, which is what? Which is 3. 3 can divide in both 3 and also in what? In 2. So these have a common factor. So when it's like this is what? Not rational. But when we write 1 over 3, it is what? It is irrational, because it is rational. I mean, this is rational. So 1 over 3 is rational because 1 over 3 has no common element and it can be expressed in the form a over b. So that is what we are going to write on. So now, from this stage, what am I going to do? So what do I do next? So what we do next is, since we've supposed that root of 2 is what? Is rational, meaning it can be expressed in the form a what? Over b. So we've said this. So now, if we've said this about root of 2 over 3, how are we going then to move? So I can square both sides. So when I square there and square there, I'll have that I have 2 to be equal to a squared over b squared. 2 equal to a squared over b squared. Okay, so now from here I can multiply b squared. Okay, I can multiply there, cross multiply, then I'll have 2b squared is equal to a squared. 2b squared is equal to a squared. So now what this means is that I can get a squared if I multiply a certain what value, which is b squared in this case, by what, by 2. So this implies that I can get b squared. I can get my b squared if I divide what, a squared by 2. So I can get my b squared if I divide a squared by what, by 2, which means that a squared is what, is divisible by 2, which means that a squared is divisible by 2. Okay, so now if a squared is divisible by 2, that implies that a squared is what, a squared must be even. By what? By definition. So if a squared is divisible by 2, meaning a squared has to be what? To be even. So if a squared is even, it means a as well has to be what? Even. So if I have a square of a number that is even, meaning even when the square is removed, that number has to be what? Has to be even. So a also is what? Is even. And if a is even, meaning by definition, if a is even, meaning a is equal to what? 2 times any what? Constant. So k be any what? Any constant. So this means that a is what? A is even. So we'll go back now to this what? To this other part of the equation where we left from. So we said 2b squared is equal to a what? A squared. 2b squared is equal to a squared there. So I can get this and replace. So I'll say 2b squared 2b squared is equal to, so where there's a squared, I can replace my 2k, then I square that. Alright, so from here then I'll have that 2b squared is equal to, so here I have 4k squared. 4k squared. So let me erase the upper part of the board. So okay, so I have that 2b squared is equal to 4k squared. So which means b squared is equal to 2k squared. Okay, so now which means that I can obtain my k squared by dividing by 2. So if I divide 2 both ways, both sides, I'll get that k squared is equal to b squared over 2. So this means that my b squared is what? Is divisible by 2. Is divisible by 2, and if it's divisible by 2, meaning b squared is what? Is even. And if b squared is even, meaning b as well is what? Is even. So now from here we'll see that we now have a what? A contradiction. So where does this contradiction appear, or where does this contradiction come in? So a contradiction comes in that when starting we made an assumption. We made an assumption to say that a over b, these have no common what? Factors. But now we see that a is even, and what? And b as well is what? Is even from what we've worked out. And if these two are what? Are both even, it means that they have what? They have a common factor. Since they are all even, a and b, both of them are even, meaning that they have a common factor, and you can divide a and b. So if you can divide a and b, and these are even, then that will contradict with the assumption that we made to say that root of what? 2 is equal to a over what? Over b. So our assumption that we made to say root of 2 is equal to a over b means that a a over b is what? A over b is rational. But since they have a common factor, it means that a over b is what? Is not, this is not what? Is not rational. So if this is not rational, meaning that uh, it has to be the opposite of what? Of our assumption which we made. So if this is not rational, meaning root of 2 is not equal, so root of 2 is not equal to a over b. And so if root of 2 is not equal to a over b, it implies that root of 2 is irrational. Root of 2 is what? Rational, irrational. So that is how you prove this question by contradiction. Thank you.